I've already launched Desmos. The link to this is in your project. And I'm going to be using a mean of 1,000 and a standard deviation of 100 in mine. You're going to be using something different in yours, whatever's on your project. But regardless, if you want to use Desmos for this, you're going to start out by typing normal, DIST, short for normal distribution, hit open parentheses, and type your mean and your standard deviation. And then type find the cumulative probability. Now you probably just see a horizontal line or nothing over here because we're not looking at the part of the graph that has 1,000 in it. So I would first go to settings, and whatever number you have here, I would choose a number, I don't know, maybe half the size of your number, and then going to maybe your number plus however much less than your number, like here it's 500 less, so here I'm going to go 500 more, and maybe have it step by 100. That means the numbers are 100 apart. And if you look at this, let me leave it just for a second, you can't really see the peak of this yet because we haven't changed the y values yet. But if we go in and say, well, let's just look between 0 and say 0.1. Now if we look at this, we start to see it, and you can keep adjusting the value until you get to where you can see the distribution well. I kept adjusting it earlier, and I found that 0.005 as a top shows it really well. One part of your project asks you to find the top 30% of the data. So let's do that one. You can do all the rest the same. And to find the top 30% of the data, we want all the data from some minimum value off completely to the right. And so we might take a guess that what if it's 1,200? This will be way too small. That's only 2% of the data. So then I could try 1,100. Now we've got 15% of the data, and we're looking for 30% of the data here. So let's go to 1050, say. That's pretty much spot on. It just needs, we need to have a little bit less data, so we want to move this line over here so we capture a little less data. So 51, 52, 52, we're about 1,500ths above it. And if we go to 53, we're a little more than that below it. So 1052 would be the best score for 30% of the data being above, 30% shaded here. And you can do this for the 15%. You probably don't have to do it for the 50%. You can probably be clever about that or use algebra. And you can also do it for the 75%, looking for when 75% of the data is bigger. Just remember, you're not going to be doing a mean of 1,000 and a standard deviation of 100. You'll go ahead and use the numbers that you have for yours.